Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. Now, we are having this question on equilibrium, and yeah, let us analyze it and we see how far we can go with it. It says, consider the hypothetical reaction below, which reaches equilibrium at 10 degrees. So what do we have here? We are having the equilibrium. The temperature is increased to 20 degrees. It was 10, then it was increased to 20. State the effect this will have on the rate of reaction. Actually, many people confuse shifting of equilibrium and rate. Whenever a question comes about rate, you have to go straight to the 6 factors, and temperature happens to be one of them. So temperature affects the rate of reaction. Increase in temperature increases the rate of reaction. Thank you. Yes, then comes this equation. We said temperature was increased on that equilibrium. What is the effect on the yield? So to answer this question, it requires you to have the equilibrium. Let us see what the equilibrium looks like. Okay, this is the equilibrium. And when it comes to temperature, you go this side and look at the enthalpy change. This one is less than 0. Less than 0 means the reaction is exothermic. And whatever is here represents forward. So the forward direction of this reaction is exothermic. So which means that the reverse is opposite, meaning endo. So temperature is increased. You have to remember also that increase in temperature favors endo and decrease in temperature favors exo. So in this case, temperature is increased and it favors what? Endo. Endo is the reverse. What does reverse mean? That the products are going to decrease and the reactants are going to increase. And the answer is already given. Yield means product. So what happens to the product? Answer is it decreases. Thank you. Yes. Then comes the next question. We said temperature was increased. What is the effect on the Kc value? We have to remember that Kc value is affected by only one factor, and that is temperature. Okay, how does it affect? It depends on the type of reaction, whether the reaction is endothermic or exothermic. If the reaction is exothermic, increase in temperature decreases Kc, and the decrease in temperature increases Kc. If the reaction is endothermic, increase in temperature increases Kc, and the decrease in temperature decreases Kc. So what do we say? The reaction is exo. Okay. So if it's exo, and the temperature has increased, what will happen to the Kc? It will decrease. Thank you. Okay, then comes this question. It says the number of moles of A. How does increase in temperature of this equilibrium affect the number of moles of A? So to answer that question, we need to have the equilibrium. Let us have it. Okay, this is the equilibrium. And we are saying that what we have here is for the forward. So forward is exo. Reverse is endo. And the increase in temperature favors endo. So what will happen? This one is going to decrease and this one will increase. That's what the verse means. And we're asking about A. So what will happen to A? Answer is increase. Okay. Then we got the next question. Okay. Then comes next question. The activation energy. What does the question say? Temperature was increased from 10 to 20. What is the effect on activation energy? So to answer this question clearly, we need to have a sketch of Maxwell energy distribution curve. Let us try to see it. Probably it will have a good to throw a good light on what we are supposed to do. Now this diagram can help us to understand the effect of change in temperature on activation energy. Okay, this is what we see. We are seeing this one at T and this one at this might be T1, this one might be T2, where T2 is greater than T1. Okay, two graphs having at different temperatures, but what do we notice? That our activation energy has not shifted. So what can we learn from here? That temperature has no effect on activation energy. So the answer is no effect. Okay, let's go to the next question. Okay, now we are having this one, question 4.16. It says position of equilibrium. Yeah, in other words, what will happen to the position of equilibrium when temperature is increased? I prefer to have the equilibrium, so let us have it. Okay, like before we have the equilibrium. And from the equilibrium, we know that this one is exo. And we know that this one is endo. Increase in temperature favors endo. Endo means reverse. And that's the answer for the position. What's the position? Reverse direction is favored. Okay. Okay. Then comes this question. Potential energy of the product. The question says that if temperature is increased, what is that change? What's the effect of that change on the potential energy of the product? The answer is no effect. Change in temperature has no effect on potential energy of the product, on potential energy of the reactant, on activation energy. So answer is no effect. Okay. Then comes the next question. Okay. Then comes this question, heat of reaction. The question says that if temperature is increased of that equilibrium, what is the effect on the heat of reaction? Okay, you have to remember that change in temperature has no effect on activation energy, no effect on the potential energy of reactant, no effect on potential energy of product. So obviously it will not have any effect on enthalpy change or heat of reaction. So the answer is no effect. Then lastly on this video, the rate of the reverse reaction. What does the question say? If you increase temperature, what will that have? What effect will that have on the rate of the reverse reaction? Okay, we have to know that temperature is one of the factors which increase the rate of reaction. But now we need also to know that it increases both forward and reverse reaction. So the answer is increase. So with that, we would like to cut this video here, and we are not going to get tired of thanking you to stay with us, for subscribing, for liking. Please, if the video has an impact on you, if the video has proven to be helpful, please like and also recommend it to a friend. The channel is PSSB, Physical Sciences Silver Bullet, and it's me, Richard. See you next time. Bye.